This video is on absolute value equations. We're actually going to be focusing on the equations and being able to solve for the equations to figure out what answers will make the equations true. The first step that we're going to have to follow is we have to isolate the absolute value. That means we're going to use order of operations to get the absolute value alone, and then we can solve. But once we get the absolute value alone, once we do this, then, so right after this, then you determine if you can continue. Because sometimes you won't even be able to continue after this, and you want to know if you can, because you don't want to have to do everything if you can't continue. So once you get this and you determine if you continue, you look here. So the question is, can this happen? The absolute value of x equal to a -3. The absolute value is a positive. It has to give you a positive value. So an absolute value can never give you a -3. So no, this cannot happen. The absolute value of x, of anything inside of here, must equal to a positive number. So if you have variables, you could continue it. But the thing is that if you have absolute value of x is equal to a negative number, you're automatically done. You can't do anything, and it's a no solution. But if you have your absolute value isolated and it's equal to a positive, you would continue. So once we have them isolated, we would take the absolute values away, and we'd say without the absolute value bars, we're going to set the inside equal to the original version. Set equal to the original version. But then we're also going to have to, without the absolute value bars, we're going to set the inside part equal to the negative version. Because since we're not going to have the absolute value bars anymore, it can equal to a negative. But if the absolute values are there, you can't have it equal to a negative. So we're going to take the absolute value bars away, because we want to know what value in here could give us, so a positive value, the absolute value of a positive will give you the positive. The absolute value of the negative will also give you a positive. So we want to know what two values could potentially be in here that'll give us the same answer. We're going to solve for x in both versions, and then we have to check our answers. If you don't check your answers, you could end up with what's called extraneous solutions. So we're going to solve for each absolute value equations, and we're going to check for extraneous solutions. An extraneous solution is a false solution. You did nothing wrong, but it actually just does not work in the equation, because when you plug it back in, it doesn't give you the same answers. So on here, we're going to do a couple of examples. We want to isolate the absolute value. So I'm going to box up my absolute value in my light blue. And I need to make sure there's nothing attached to that light blue. Since nothing is attached to the light blue, I have isolated it. Now determine if I can even continue. This number is positive. That means I can continue. So I'm going to go without the absolute values. I'm going to go down here and set up my two equations. So I'm going to do my first equation without the absolute values, the original version. So this is 3 plus 4x is equal to that positive 23. The second version is I do not change anything from the inside. That stays the same. I'll have a 3 plus 4x, but now it will be equal to the negative part on the other side. So negative times 23 is negative 23. Now we're going to solve for x for both versions. So I'll subtract the 3. I'm going to solve for this side first. So I'm going to have 4x is equal to 20. So I'll have x is equal to 5. I'm not going to highlight it. I'm not going to box it up. I'm not going to say I'm done yet. I'm going to do the same thing over here. I'm going to subtract the 3. So I'll have 4x is equal to negative 26. Divide by 4. We'll get x is equal to negative 13 over 2. So again, I'm not going to box them up or highlight them because I'm not finished. We have to then check our answers. So I'm going to draw a little dotted line here. I'm going to break it up so I can do my checks. So I need to plug my answers back into the original to see if it does come out correctly. So for this side, I'm going to have the absolute value of 3 plus 4 times that x of 5, absolute value, is hopefully equal to 23. Then we have the absolute value, I'm just going to simplify this, 3 plus 20 is supposed to equal to 23. So the absolute value of 23 is supposed to equal to 23. The absolute value of 23 is 23. It works. So that means that x equals 5 does work. But then I'm going to check the negative 13 over 2 the same way. So I have the absolute value of 3 plus 4 times negative 13 over 2. Absolute value is hopefully equal to 23. So we have the absolute value of 3 minus 26, because 4 times negative 13 divided by 2 is a negative 26, is hopefully equal to 23. 3 minus 26 is negative 23, but it's in the absolute value bars. So the absolute value of negative 23 is positive 23, so this also works. So both of our answers work. That means I could rewrite them. I'm going to rewrite them in red. X is equal to 5, and x is equal to negative 13 over 2. And that means I can highlight these as my answers because they did work in the check. This is why we have to check them, because you could end up with extraneous solutions. On the next example, again, I'm going to isolate the absolute value. So I'm going to box up this in light blue so I can get everything away from it. To get everything away from it, I actually have to add that 5 to the other side. So I'll have the absolute value of x plus 8 is equal to a positive 7. Now I'm going to check if I can continue. The absolute value is equal to a positive, so I can keep going. So I'm going to separate them into 2. I'm going to write out the original one without the absolute value bars. So I'll have x plus 8 is equal to that positive 7. But the other one I'll have is x plus 8 is equal to the negative 7. So the inside, again, does not change at all from the beginning until you set up your equations. So now I'm going to solve for x. I'm going to have x is equal to, I'm going to subtract 8, negative 1. And then subtract 8 here. I'll end up with x equals negative 15. Now we got to check them. So I'm going to draw a little line here. So we have, in the original, the absolute value of negative 1 plus 8, absolute value, minus 5 is hopefully equal to 2. So we have the absolute value of 7 minus 5. The absolute value of 7 is 7, so 7 minus 5 is equal to 2. So 2 is equal to 2. It's good. So since 2 is equal to 2, I know that this answer did work. So let's try the negative 15. So again, the absolute value bars, negative 15 plus 8, absolute value, minus 5 is equal to 2. We have the absolute value of negative 7 minus 5 is equal to 2. The absolute value of negative 7 is 7 minus 5, and 2 is equal to 2. So that also works. So again, check your answers. So x equals to negative 1, and x equals to negative 15. We do check them. So now I can highlight them. On example 3 here, so again, we're going to isolate. So I need to box up my absolute values so I can get everything away from it. So the first thing we have to get away from it, we have a negative 5 multiplied to it and a 2 added to it. We need to subtract the 2 first. So we'll have that negative 5 absolute value of 5x minus 5, absolute value, is equal to a negative 75. We have to actually get the absolute value alone first before we can determine. Because right now, this wouldn't work. But we still have that negative 5 over here. We have to divide by negative 5. Again, do not do anything to inside the absolute values. That has to stay as is. It's like these are bars you cannot cross into. So we have the absolute value of 5x minus 5, absolute value equals negative 75 divided by a negative 5 is a positive 15. Now that it's isolated, it's equal to a positive, and we can keep going. So we're going to set it up without the absolute values to the original. So we're going to have 5x minus 5 is equal to 15. And then we'll have 5x minus 5 is equal to a negative 15. We're going to add the 5. So we're going to have 5x is equal to a positive 20. and then x is equal to a positive 4 because you divide by the 5. Same thing over here. I'm going to add the 5. End up with 5x is equal to a negative 10. Divide by 5, we get x is equal to a negative 2. So we have to check. So we have to put into the original. We have negative 5, absolute value of 5 times 4 minus 5, absolute value, plus 2 is equal to a negative 73. So 5 times 4 is 20, minus 5 is 15. The absolute value of 15 is 15. So this is really negative 5 times 15 plus 2. Because we can do the absolute value of this, does give us the 15, we can just multiply negative 5 times 15 will give us that negative 75 plus 2 gives us negative 73 is equal to negative 73. So that one does work. X equals 4 works. We're going to do the same thing with the negative 2. So negative 5, absolute value of 5 times negative 2 minus 5, absolute value, plus 2 is hopefully equal to negative 73. So again, we're going to look at this. This is negative 5. 5 times negative 2 is negative 10. Minus 5 is negative 15. So this is negative 15 inside the absolute value. The absolute value of negative 15 is a positive 15. So we're just multiplying by positive 15 again. We're going to add 2. This is the same thing as above. So this is negative 75 plus 2 is negative 73 equals to negative 73. Also good. So both of these answers work. So x equals 4 and x equals negative 2 both work. We're going to highlight both of those.